everybody. Welcome to chemistry. Today we're going to start our next unit, which is our big math in chemistry unit. It's about the unit moles. So today, basically, we're going to learn what a mole is and learn how to perform one calculation that's going to be the foundation, essentially, for the rest of the unit. So if you'd like to take notes, get your note packet number 6 out. We're going to get started here with learning about what a mole is. All right. It would be cute if a mole was a little furry critter that we may or may not have seen here on planet Earth. That's one kind of mole. But in chemistry, a mole is not an animal. It refers to a very specific number of particles. And that number you're looking at right here on the screen, it is 6.02 times 10 to the 23rd particles. Now, those particles can be atoms, can be ions, can be entire molecules. But if I tell you you have 1 mole of something, I am telling you you have this many of it, 6.02 times 10 to the 23rd. The big foundational skill that we're going to learn today is how you would calculate the mass of 1 mole of particles, that many, for a given substance. For example, if you had exactly 6.02 times 10 to the 23rd carbon atoms, and you were to put them on a scale, that scale would say approximately the mass of that 1 mole of carbon atoms would be 12 grams. All right, so a mole is a very specific number of particles. And what we're going to learn to calculate today is for a given substance, the mass of 1 mole of particles of that substance. All right, so basically a mole, again, in chemistry, it's not a cute, fuzzy little animal. Instead, it's a specific number of particles, and that number is constant from one substance to the other. So again, if I tell you you have a mole of something, what I'm saying is you have 6.02 times 10 to the 23rd of that something. Now, Avogadro, his name may seem familiar. He is a scientist we talked about earlier in the year. He did experiments with gases. He's the one that said if you have equal volumes of a gas at the same pressure and temperature, they would contain the same number of molecules. He also came up with the whole concept of a mole, that 1 mole of anything is equal to this many particles of that thing. All right, so a mole, a certain number of particles, and it's always 6.02 times 10 to the 23rd. Okay, so today what we're going to really learn how to do is calculate the mass of 1 mole of any substance that we could basically come across. So it could be a mole of atoms or a mole of molecules. And there's a couple names for the mass of 1 mole of particles. It's called the Gram formula mass. Gram formula mass, which is often what I'm going to call it, or the molar mass. I often will abbreviate gram formula mass as GFM. So what we're really going to learn to calculate again today is if I had, say, a sample of carbon, and I said I had 1 mole of, say, carbon atoms, which means I would have 6.02 times 10 to the 23rd carbon atoms, and I was to put that 1 mole of particles, all those particles on a scale, what would be the approximate mass of those particles in grams? So the mass of 1 mole of particles is known as the gram formula mass, also known as the molar mass. All right, so we'll start with a simple one. What if I wanted to know the mass of 1 mole of salt, sodium chloride? Right? If I had 6.02 times 10 to the 23rd molecules of sodium chloride, and I put them on that scale on the screen, what would be their approximate mass in grams? All right, step 1 is this. You look at the formula that you're given, and you determine the number of each type of atom in the formula. So, for example, NaCl has 1 Na and 1 Cl. Next, you're going to look on the periodic table and take the atomic mass of that element and basically just say that that would be the mass of 1 mole of that element in grams. So for example, if I had 1 mole or 6.02 times 10 to the 23rd atoms of sodium, and I put those 6.02 times 10 to the 23rd atoms of sodium on a scale, the approximate mass would be 23 grams. Now, where am I getting the 23 from? I'm rounding the atomic mass in the upper left-hand corner to the nearest whole number. So 22.98977 would round to 23. All right, so basically, you're going to take that atomic mass in the upper left-hand corner and round it to the nearest whole number. And then you're going to multiply the number of each atom or each element in the formula times the atomic mass in grams from the periodic table. So we just saw sodium in NaCl, but we're trying to calculate the GFM for the mass of 1 mole of sodium chloride molecules. I have 1 Na and 1 Cl. I would multiply the number of atoms of each element by the rounded mass from the periodic table. We just saw sodium's mass rounds to 23. Chlorine's mass, you have to take my word for it, would round to 35. And then the last step would be to add those results together. And that is the approximate mass in grams of 1 mole of particles of whatever substance you're performing this calculation for. So the unit here for the gram formula mass is going to be grams per mole. Because what you're saying is if I had 1 mole, which is 6.02 times 10 to the 23rd molecules of sodium chloride, and I put all of those molecules on a scale, the approximate mass of all of those molecules would be 58 grams. So it's grams per mole, the mass of 1 mole of a given substance. The mass of 6.02 times 10 to the 23rd particles of, in this case, sodium chloride is 58 grams. All right, so summary, and then we'll do the let's practice. If I had 1 mole of anything, sodium chloride molecules, just plain sodium atoms, even sodium ions. If I tell you you have 1 mole of something, you have exactly 6.02 times 10 to the 23rd of that something. What we learned to calculate, the GFM, the gram formula mass, would be the mass of 1 mole of particles of a given substance. Like we just figured out, if we had 1 mole of sodium chloride molecules, 6.02 times 10 to the 23rd of them, their approximate mass in grams would be 58. The units for this are grams per mole. Grams per 1 mole of a substance. All right, so let's work on this, and then you're going to take your quiz, and then after the quiz, you're going to work on a practice. I know I'm not here today, but do the best you can without me. This is the foundation for the rest of the unit, being able to perform this calculation. All right, so I'll go quickly here. I want to know how many molecules are in 1 mole of sodium sulfide. Honestly, it doesn't matter the substance I'm giving you here. If I ask you how many particles, like how many molecules, are in 1 mole of anything, sodium sulfide, water, sulfur atoms, sodium atoms, every time you have 1 mole of something, the amount of particles, or molecules in this case, is 6.02 times 10 to the 23rd. 1 mole of whatever is always equal to that number. Now, what is the gram formula mass of sodium sulfide? What is the mass of this many particles of sodium sulfide? Well, first we have to figure out the formula. I'm not going to make you do this in the practice, but in the future I might. Remember, to get a chemical formula, you would write the symbol for each element. Sodium is Na. Sulfide refers to sulfur. Sodium is +1 in terms of its oxidation state. Sulfur's only negative oxidation state is -2. Whether you use logic or the cross-down trick, you end up with 2 sodiums for every 1 sulfur. So I'm going to find the mass of 1 mole, 6.02 times 10 to the 23rd particles of Na2S. All right, I like to go ahead by starting to write the symbol for each element in the substance. So I have sodiums and sulfur. I then would record how many sodiums I have, which in this case would be 2, and how many sulfurs I have, which in this case would be 1. I then multiply the number of each element by the rounded mass from the periodic table. Sodium's mass rounds to 23, so we're going to round to the nearest whole number. Sulfur's mass of 32.065 would round to 32. 2 times 23 is 46. 1 times 32 is just 32. The very last step to get the gram formula mass, or the mass of 1 mole of sodium sulfide particles, would be to add those two together. 46 plus 32 comes to 78, and the correct units would be grams per mole. So what we just figured out is if we had 1 mole, or this many particles of sodium sulfide, and we put them on a scale, the approximate mass of those particles would be 78 grams. Okay, now you're going to take about a couple minutes, get ready for your quiz. You're going to take your quiz, and then after your quiz is over, there's going to be a practice on this that posts on the portal. Please take that practice seriously, because like I said, this is the foundation for the rest of the unit. Obviously, I'll help you when you get back, but do your best you can without me. All right, bye guys. See you soon. Hold on, I think it's still recording. What the heck? Oh.